A 3-kilogram dog runs in a straight line. The velocity of the dog is shown in the diagram as a function of time. What is the maximum force the dog exerts? When does the dog have a zero net force in its motion? So let's go ahead and set up this problem. First, let's identify any relevant concepts, given information, as well as our target variable so we know what we're trying to attack. For starters, let's go ahead and note what is the target variables. First, we're looking for F max, and we're also looking for the time when the net force equals 0. So these here are the target variables that we're going to be looking for in this problem. Now for what was given, we had the mass equaled 3 kilograms and also a velocity versus time graph. Now when we start looking at what is the relevant information and the concepts that we can use to solve this problem, we're going to come up with Newton's second law. So that will be indicated here. Well, Newton's second law has a mass and an acceleration. We were given a mass over here, and we were given a velocity versus time. So what we need to do is figure out how to turn the velocity versus time graph into some accelerations. Well, that's very easily done. The only thing we need to do with a velocity versus time graph is to find the slope of each of the line segments. So, if you remember, acceleration is equal to dv over dt, which is really the change in velocity over the change in time, which can also be just your simple slope of rise over run. And this is only going to be for the velocity versus time graph. So the three accelerations that we were given, A1, A2, and A3, are going to be 1.5, or actually, the first one's going to be 1, the second one's going to be 1.5, and the next one's going to be 0. Let's go back and take a quick look at those. So what we're looking at is this portion here for A1, and then we're looking for this second portion here is A2, and finally this last portion here is A3. As you can see, if we did a rise over run for this portion here, the top is a 0, so that's going to be 0. For the second portion here, we have a rise of 6 and a run of 4. For this first portion here, we have a rise of 4 and a run of 4. So that will give us the 1 that we found for this portion, the 2 we found for this portion, and the 0 that we found for this portion. Actually, this is 1.5, not 2. So that's just a quick look at how I actually found the accelerations. Now that we have the accelerations and the mass, all we need to do is find the two target variables that we were given. So again, the formula we're going to be using in our setup is the sum of the forces, and we're going to label this in the x direction, equals the mass times the acceleration. So that's going to be A1, A2, and A3 that we're going to be plugging in. So let's go ahead and execute that. We have f of x sub 1 equals 2, which is the mass, times our first acceleration. We have f of x2 equals 2 times 1.5. And then we also have f of x3, which equals 2 times 0. Now let's figure out what all of these are. The first one is going to equal 2. The second one is going to equal 3. And the third one is going to equal 0. Now remember, all of these are in newtons. So we were looking for F max, F max is found here. And we're also looking for the time that the force was actual zero, the net force, and that's found here. Now we can't actually find the time from this. We have to go back and look at the graph. And if you look at the graph, this is going to be any time that t is equal to or greater than 8 seconds. So here is our answer, and here is our other answer. Now comparing these answers that we found to the graph that was given, we have the last portion that was straight. So that seems reasonable for the 8 seconds, and everything beyond that we have a zero force. Even though the dog is still going to be continually moving, he has a zero acceleration. So anything in a constant motion like that is going to be experiencing a zero net force. And compared to the other two portions of the graph, where we found the acceleration 1 and the acceleration 2, we do notice that the slope of the second portion is much larger than the slope of the first portion. So we do have a greater acceleration, and that will be the greater time, or the time period where the greater force is being applied by the dog.